Skittles produces 200 million individual candies every single day. That's 73 billion pieces per year from a handful of factories worldwide. The process involves industrial-scale sugar manipulation, color engineering that borders on food science wizardry, and quality control so precise that machines reject candies if they're zero point 0.2 grams too light. This isn't small batch artisan candy making. This is mass production engineered for absolute consistency at incomprehensible scale. Here's how Skittles actually get made, why every piece tastes identical despite being manufactured by the billions, and the engineering challenges most people never consider when eating rainbow candy. Everything starts with sugar, not table sugar from your kitchen, but industrial refined sugar that arrives at the factory in 2,000-pound bags. This sugar gets combined with corn syrup, hydrogenated palm kernel oil, and citric acid in massive steel tanks that hold 500 gallons each. The mixture gets heated to exactly 293 degrees Fahrenheit while being stirred continuously by industrial mixers spinning at 200 revolutions per minute. Here's why temperature matters so much. Below 290 degrees, the sugar mixture won't reach proper consistency. Above 295 degrees, it starts caramelizing and turns brown. Industrial sensors monitor temperature 100 times per second and adjust heating elements automatically. If temperature drifts by even 2 degrees, the entire 500-gallon batch gets rejected because the final texture will be wrong. But here's the part that surprises people. This heated sugar mixture doesn't become Skittles directly. It becomes the foundation core that will later get coated. The mixture gets pumped through pipes to molding machines while maintaining exact temperature. If it cools too much in the pipes, it solidifies and clogs the entire system. If it stays too hot, it won't hold shape in the molds. The margin of error is seconds. The molding machines are the first engineering marvel. Each machine has 1,000 tiny dome-shaped molds arranged in rows. The hot sugar mixture gets deposited into each mold simultaneously through a system of precisely timed nozzles. Each mold gets exactly 0.9 grams of mixture. No less, machines deposit mixture into all 1,000 molds in 1.2 seconds. Then the molds move forward and a new set rotates into position. Once the sugar mixture fills the molds, cooling must happen under controlled conditions. The molded pieces enter cooling tunnels that are 150 feet long with temperature zones dropping progressively from 250 degrees to 65 degrees over 20 minutes. This gradual cooling prevents cracking. If you cool them too fast, causing the centers to rupture. Here's why the tunnels are so long. Skittles aren't solid candy like hard candy. They have a chewy texture that requires specific crystalline structure in the sugar. Fast cooling creates large sugar crystals that make the candy grainy. Slow controlled cooling creates small uniform crystals that create smooth, chewy texture. The tunnel length and temperature gradient are calculated to produce exactly the right crystal size. But here's what happens if cooling goes wrong. The centers become too hard, too soft, or develop inconsistent texture. Every single batch gets tested by quality control before moving to the next stage. Workers bite into random samples from each batch, checking for proper chewiness. By the time centers exit the cooling tunnel, they're hardened, chewy cores ready for coating. These centers are completely white because no color has been added yet. The rainbow comes later through a coating process that's far more complex than dumping food coloring on candy. This is where Skittles become Skittles. The white centers get loaded into massive rotating drums called panning drums. These drums are 8 feet in diameter and rotate continuously at 15 revolutions per minute. Each drum holds 200,000 centers that tumble constantly while liquid coating gets sprayed over them. The coating isn't applied all at once. It's built up through 30-40 separate applications over 6 hours. Each application adds an incredibly thin layer that must dry before the next layer gets applied. Too much coating at once, and the pieces stick together. Too little, and the shell doesn't form properly. The layers build up like paint, each one microscopic in thickness. Here's the engineering challenge. You're trying to coat 200,000 tumbling pieces uniformly. Pieces at the top of the drum tumble get more spray than pieces at the bottom. The drum's rotation speed, spray pattern, and liquid viscosity must be perfectly calibrated so every piece gets identical coating despite constant movement. Cameras inside the drum monitor coating thickness on sample pieces 500 times per minute. The coating liquid contains titanium dioxide for white base, then food dyes for colors, then more titanium dioxide, then dyes again. Each Skittles shell has at least 12 layers of different materials. The early layers provide the white base that makes colors vibrant. Middle layers add the actual color. Final layers seal everything and create the smooth, glossy finish. But here's what makes this complicated. Different colors require different numbers of layers to achieve identical color saturation. Red requires 8 layers of dye. Yellow requires 12 layers of dye. Green requires 10 layers. This means the drums must run different coating cycles depending on which color is being produced. A drum making red Skittles finishes in 5 hours. A drum making yellow Skittles takes 7 hours. Each color gets manufactured in dedicated panning drums. You don't make all 5 colors simultaneously in one drum. That would be impossible to control. Instead, 5 separate drums run simultaneously, each producing a single color. This allows precise control over each color's formulation and appearance. The color spray systems are incredibly precise. Food dye gets mixed with liquid sugar and binders, then atomized through spray nozzles that create droplets 50 microns in diameter. That's smaller than human hair. These microscopic droplets coat the tumbling centers evenly because small droplets dry faster and create smoother layers than large droplets. Here's why atomization matters. Large droplets of coating liquid create uneven surfaces with visible texture. Small atomized droplets create mirror-smooth surfaces. The difference between professional-looking candy and amateur candy is droplet size. Industrial spray systems use compressed air at 100 psi to atomize liquid into the finest possible mist. But here's the quality control problem. Food dyes are sensitive to light, heat, and pH changes. A batch of red dye from morning might be slightly different from a batch in afternoon due to ambient temperature differences. Spectrometers continuously measure the exact color of coating liquid and adjust dye concentration automatically to maintain perfect consistency. Every red Skittles must be identical to every other red Skittles regardless of which batch or which day it was made. The color coding continues for hours. Spray for 30 seconds. Dry for 2 minutes. Spray again. Dry again. Repeat 40 times. The drums never stop rotating. If rotation stops, coating pools on one side and pieces stick together. If rotation is too fast, pieces crash into each other and chip the developing shell. The optimal rotation speed was determined through years of testing and is now maintained by computer control. Once the colored shells are complete, every single Skittles gets an S logo printed on it. This happens through edible ink printing technology that works like an inkjet printer, but for candy traveling at high speed on conveyor belts. The candies travel single file on conveyors, moving at 3 feet per second. High-speed cameras identify the top surface of each candy. Inkjet print heads spray edible titanium dioxide ink onto the top surface as it passes underneath. The entire process happens in 0.3 seconds per candy. The camera identifies position. The printer fires. The essay appears. The candy moves on. Here's why this is harder than it sounds. The candies aren't perfectly aligned. They're tumbling slightly as they travel. The camera must identify the highest point of each candy, calculate trajectory, and signal the printer to fire at exactly the right millisecond to hit the center of the top surface. Miss by 2 millimeters, and the S prints off-center. The candy gets rejected. But here's the fail rate. Approximately 2% of candies get rejected at the printing stage. Either the CES didn't print clearly, printed off-center, or the candy was oriented wrong and got printed on the side instead of top. These rejected candies get sorted out by optical sensors and sent back to be melted down and reprocessed. No imperfect Skittles leave the factory. The edible ink is titanium dioxide suspended in ethanol with food-grade binders. Titanium dioxide is the same white pigment used in the candy shell, but at higher concentration for opacity. The ethanol evaporates in seconds after printing, leaving behind a permanent white set that won't smudge or fade. After printing, you have 5 separate production lines, each making a single color. Now they need to be mixed into bags with perfect color distribution. This is harder than dumping 5 colors into one hopper. Here's the problem. If you just combined 5 colors randomly, some bags would have mostly red and green, other bags would have mostly yellow and purple. Customers expect approximately equal amounts of each color. The mixing must be controlled. The 5-color conveyors feed into a sophisticated blending system that weighs incoming candy from each color in real time. Optical sensors count how many of each color are entering the mixer per second. If too many reds are flowing, the system throttles back the red conveyor and speeds up the purple conveyor. The goal is perfectly balanced color input, so the output is perfectly balanced color mix. But here's why weighing matters. Each color isn't exactly the same weight because coating thickness varies slightly. Red Skittles average 1.03 grams. Yellow Skittles average 1.07 grams because yellow requires more coating layers. If you counted pieces instead of weighing, you'd get uneven weight distribution in bags. Customers care about net weight more than piece count. The blended candy gets fed into packaging machines that fill bags at a rate of 150 bags per minute. Each bag must contain exactly 61.5 grams of candy. Machines weigh each bag before sealing. Too light and more candy gets added automatically. Too heavy and excess gets removed. The tolerance is plus or minus 0.3 grams. Throughout the entire process, quality control removes imperfect candy at multiple checkpoints. Sensors check if centers are proper weight. After coating, sensors check if shells are uniform thickness. After printing, sensors check if logos are centered. Sensors check if color distribution is balanced. Each checkpoint rejects 1 to 3% of production. Here's the math on rejections. Producing 200 million Skittles per day with a 2% average rejection rate means 4 million pieces get rejected daily. That's 1.46 billion rejected pieces per year from a single factory. These rejected pieces don't go to waste. They get melted back down and reprocessed into new centers. Nothing leaves the facility except perfect candy. But here's what quality control actually tests for. Weight must be 1.0 to 1.1 grams. Diameter must be 9.8 to 10.2 millimeters. Shell thickness must be 0.4 to 0.6 millimeters. Color must match reference samples within 3% variation measured by spectrometer. Logo must be centered within 1 millimeter. Surface must be free of any chips, cracks, or imperfections. X-ray machines scan every candy for foreign objects. Metal detectors check for any metal contamination from machinery. Air jets blow across the surface to remove any loose coating particles. Candies that fail any test get ejected from the line by precisely timed air blasts that knock them into reject bins while good pieces continue forward. Human inspectors also pull random samples every 15 minutes and examine them under magnification. They're checking for defects that machines might miss, subtle color variations, texture inconsistencies, or coating imperfections. If inspectors find problems that machines didn't catch, the machines get recalibrated immediately. Let's put the numbers in perspective. One factory produces 200 million Skittles per day. That's 8.3 million per hour. 138,000 per minute, 2,300 per second. Visualize that. Every single second, 2,300 individual pieces of candy are being molded, coated, printed, sorted, and packaged. Here's what that requires physically. 50,000 pounds of sugar per day, 12,000 pounds of corn syrup, 3,000 gallons of food coloring, 500,000 cubic feet of temperature-controlled air for cooling tunnels, 2 million gallons of water for cooling systems and cleaning. The raw material logistics alone are staggering, but here's the energy consumption. Running the heating systems, cooling systems, rotating drums, conveyors, sensors, cameras, and all equipment requires 8 megawatts of electrical power continuously. That's enough electricity to power 6,000 homes. A single Skittles factory uses as much power as a small town. The equipment maintenance is equally intense. Panning drums must be cleaned daily because coating residue builds up. Spray nozzles must be replaced weekly because they clog. Conveyor belts must be inspected for wear. Sensors must be calibrated. Every machine has scheduled maintenance because any breakdown stops production of millions of candies per hour. Here's the economic reality. The factory operates 24 hours per day, 7 days per week, 362 days per year. Only 3 days per year are scheduled shutdowns for deep cleaning and major maintenance. The rest of the time, candy production never stops. The machines run continuously because the economics of mass production require maximum utilization. Workers operate in 3 shifts, covering every hour. Second shift handles packaging and quality control. Third shift handles cleaning and equipment maintenance while production continues. It's a 24-hour operation that never sleeps because consumer demand for Skittles never stops. Here's what would happen if quality control failed. You buy a bag of Skittles and get mostly one color, or the shells are different thicknesses, or some pieces are bigger than others, or the gas logo is smudged. You'd notice immediately and probably return the product. Brand reputation depends on every bag being identical to every other bag. Mars Wrigley, the company that owns Skittles, knows this. They've spent decades perfecting these manufacturing processes specifically to achieve absolute consistency. The industrial engineering behind Skittles isn't about making candy. It's about making identical candy billions of times without variation. But here's the broader point. When you eat Skittles, you're not thinking about sugar crystallization temperatures, atomized spray systems, or spectrometer color measurements. You're just eating candy. But all of that engineering is why every piece tastes the same, looks the same, and delivers the exact experience you expect. The factories don't advertise this complexity because consumers don't care about industrial processes. They care about consistent product. But the complexity exists because consistency at this scale requires extraordinary precision, automation, and quality control. You can't make 73 billion identical candies per year through casual manufacturing. You need industrial engineering at the highest level. That's how Skittles get made. Not by hand, not in small batches, not with artisan care. Through industrial mass production running 24/7 with computer-controlled precision, rejecting millions of imperfect pieces daily, and maintaining quality standards that most people never consider when opening a bag of rainbow candy.